Welcome to this explainer. Today we're digging into a really fascinating concept aimed at 8th graders, one that actually bridges the gap between pure math and our everyday lives. We're talking about inequalities. It's kind of amazing to see how math helps us understand the boundaries that guide our daily choices. Once you start looking at the world through this lens, I promise you're going to spot these mathematical boundaries literally everywhere, from the age limits on the apps you download to the budget you set for your weekend plans.
Now, the source curriculum actually kicks things off with a spiritual perspective, proposing that God's goodness covers a broad range. It uses this quote from Psalm 145:9, "The Lord is good to all, and his mercy is over all that he has made." The material suggests that when we think about concepts like goodness and mercy, it's rarely just one tiny specific point. It's vast, it's expansive, it covers a wide spectrum. And this idea of a broad range really acts as the perfect transition into mathematical thinking for this lesson, setting up the premise that truth, blessings, and mathematical solutions can all extend across a glorious range.
So here is our roadmap for today. 1. The divine range. 2. Meet the inequality symbols. 3. Graphing on the number line. 4. Real-life limits and ranges. And finally, 5. Morality, education, and peace. Let's jump right into section 1, the divine range. It turns out there's a massive contrast between the strict limit of an equation and the expansive freedom of an inequality. Just think about equations for a second. When you solve an equation, you get something like, well, x equals 5. That's it. Exactly one correct answer. It's super rigid. But an inequality, that represents a whole range of correct choices. It tells us not just one solution, but many values that make a mathematical statement true. It's basically the difference between being told to stand on one specific tile on the floor versus being told you can play anywhere inside an entire soccer field. So the crucial takeaway here is that inequalities help us make sense of our everyday reality. By definition, an inequality is simply a math sentence that compares two values instead of saying they're exactly equal. And in life, not everything has just one right answer. Think about it. Choosing a healthy snack, trying to save money, figuring out if you have enough time to finish a video game before dinner. In all these scenarios, multiple outcomes are totally fine. Inequalities let us mathematically describe these real-life limits where a whole range of answers is perfectly acceptable.
All right, moving on to section 2, meet the inequality symbols.
So there are 4 core symbols you're going to use to build these mathematical sentences. First up, we've got the greater than symbol, which looks like a little arrow pointing off to the right. Below that is less than, pointing to the left. But pay close attention to the bottom two, greater than or equal to, and less than or equal to. Notice that little horizontal line underneath the symbol? That's actually half of an equal sign. It's a massive clue. It tells you the target number itself is officially included in the allowed range. Master these 4 symbols, and you literally unlock the entire language of inequalities. Which brings us to section 3, graphing on the number line. The curriculum breaks graphing down into 3 really simple steps to help you visually represent your range. First, you just locate your target number on the number line. Second, you decide whether to draw an open circle or a closed filled-in circle. And finally, step 3, you draw an arrow pointing in the direction of all the other numbers that make the statement true. Easy, right? Let's actually break down step 2 a bit more because it's super important. If the value cannot be exactly equal to the target number, we leave the circle open. This shows that the boundary starts just past that number. I absolutely love this way of thinking about it. An open circle is like an open gate. You can walk right up to the number 5, but 5 itself isn't part of the solution. So for an inequality like x is greater than 5, you draw an open hollow circle exactly on the 5 and then shoot your arrow off to the right, covering 6, 7, 8, and all the way into infinity. But what if the phrase says at most or at least? Well, in that case, we fill in that circle to show that the exact number is securely included in our range. A closed circle is a solid foundation. You can stand right on it. So if we have y is less than or equal to 3, we draw a solid filled-in dot right on the number 3, and then draw our arrow to the left, capturing 2, 1, 0, and all those negative numbers down the line. Okay, let's make this practical with section 4, real-life limits and ranges. Think about the number 13. Specifically, imagine the exact moment you go to create an account online, maybe for a brand new app or a video game platform, and suddenly, boom, you hit an age requirement. The screen tells you that you must be at least 13. So how do we translate that into our new mathematical language? Well, because you can be exactly 13 years old or any age older than that, this translates perfectly to x is greater than or equal to 13. On a number line, that means a solid, closed circle right on the 13 with an arrow pointing to the right toward 14, 15, and beyond. See, you just successfully graphed a real-world boundary. The source material actually throws in some homework here with 5 practice problems to test this out. It gives us x is less than 7, x is greater than or equal to -2, x is greater than 0, x is less than or equal to 5, and x is greater than or equal to 10. Just remember your 3 steps. Find the target number, decide if that circle is open or closed, and draw your arrow. And that leads us to our final section, Section 5, Morality, Education, and Peace. Now, we've spent this explainer looking at numerical boundaries, where ranges start, where they stop, what's included and what's not. The curriculum actually ties this entire mathematical concept back to their Godly Learners series philosophy. It presents the idea that just as mathematical boundaries keep our answers accurate and logically sound, moral boundaries keep our lives safe, preventing the pain of bad choices. The core philosophy of the text is that education intertwined with biblical morality creates a truly complete learner. Because, according to the source, education alone, without a moral compass to guide it, will ultimately lead to hurt. The analogy here is that just like a number line needs to find rules to make sense, our actions need moral boundaries to keep us within the range of healthy, positive outcomes. Building on that, the text quotes Romans 8, 6-7, which says, "To be spiritually minded is life and peace." The material frames this as a promise of absolute peace of mind for those who choose to live within the spiritual range established by God. The argument is that when people embrace the boundaries set by faith and morality, they aren't restricting themselves at all. Instead, they're placing themselves safely inside a precise range where life and peace exist. The curriculum calls it the ultimate greater than equation for human well-being. I'll leave you with this crucial thought straight from this text to reflect on. What is the point of being highly intelligent and supposedly educated if you use that knowledge to make choices that fall completely outside the boundaries of wisdom and morality? It's a pretty heavy question. As we look at inequalities, the material uses it as a reminder that recognizing good boundaries, both on a mathematical number line and in real life, is the true mark of a brilliant student. Thank you so much for joining me for this explainer, and I'll catch you next time.